This is the video for section 4.4 notes, slides 26 and 27. All right, so now that we've talked about the second derivative a little bit, we want to figure out exactly what the second derivative tells us. All right, so we want to understand that if I have a graph of f that looks like this, okay, what does that mean? Well, that means that f prime is greater than 0, right? This is a graph that is increasing, and f double prime is greater than 0, which means that it is concave up. Okay, this graph is increasing, but it is concave down, and so we can say that f prime is greater than 0 and f double prime is less than 0. This graph is f prime is less than 0, right? It's decreasing, but f double prime is greater than 0. It's concave up. And this last one is where f prime is less than 0, right? Because it's concave, or sorry, it's decreasing, and f double prime is less than 0, so it is concave down. Now, these are the only 4 ways that a curve could look other than being a line, right? So if it's a line, if it's a straight line, okay, this really isn't that interesting because f prime here would be less than 0 and f double prime would equal 0 the whole time. And this one, f prime is, of course, greater than 0, but f double prime is equal to 0. So if you're worried about that scenario, you shouldn't be, because the equation would just be a linear equation. All right. So every other equation is going to have a combination of these 4 curves. All right. So this first example says, sketch a graph of f if f prime and f double prime have the following properties. All right. So f prime is negative, then 0, then negative, positive, then 0, then negative, then undefined, then positive. All right, f double prime is negative, 0, negative, undefined, positive. So really all this is a sign analysis chart, right? So we have our different parts here. F prime is above, f double prime is below. So our sign analysis chart says to the left of -1, f prime is positive and f double prime is negative. So let's take a look. Positive f prime, negative f double prime, meaning a curve must look something like that. All right, then between -1 and 1, okay, f prime is negative and f double prime is negative. So f prime negative means decreasing. F double prime negative means concave down, so we have to have a curve that looks like this. So we're going to join those 2 curves together when x equals -1. All right, and that would mean that the first derivative is 0, which is of course true because there's a horizontal tangent. Okay, all right, next, okay, to the right of 1. The first derivative is positive and the second derivative is positive. So what does that mean? Positive first derivative means increasing. Positive second derivative means concave up. So we have a curve that looks like that. So now, if I think about joining these 2 curves together at x equals 1, that would be interesting because then it wouldn't be smooth, right? It would be a corner point. Well, it should be because the first derivative is undefined, right? Now, if the first derivative is undefined, the second derivative must also be undefined. All right, and so what we want to do is we want to draw some axes, okay? And we're going to put a point somewhere at -1, okay? And then we're going to put a point somewhere at +1. Now, we don't know whether this graph, would shift vertically or not, but basically I'm going to pick a point at -1, all right? And then I'm going to draw those curves off of that. So I draw a curve off of that here, all right? I draw a curve off of that here, all right? Now, what we know is that this curve between -1 and 1 must meet this curve at x equals 1. So now my concave down decreasing curve is going to go somewhere here, and then at 1, it's going to join with that other curve, and it's going to look something like this. So this would be a graph that would resemble what this sign analysis shows. Okay, and so now what we're going to be doing is, instead of being given the sign analysis, we're going to go one step further. So what if I gave you the function and then you had to create the sign analysis and then draw the picture? So that's what slide 27 says, okay? So it says find the intervals for which f is increasing, decreasing. So that's going to be first derivative test. Local extreme values, first derivative test. Intervals for which f is concave up, concave down, second derivative test. Inflection points, second derivative test. And then provide a sketch that would be first and second derivative sign analysis combined. So in order to do this, this is a whole lot of work. So I need to find f prime. So let's start there. f prime. So the derivative of x to the 2/3 times 1 minus x. So that would be product rule. X to the 2/3 times the derivative of 1 minus x, which is -1, plus 1 minus x times the derivative of x to the 2/3. So that'd be 2/3 x to the -1/3. All right. So then I'm going to set this equal to 0 and solve. So I have 1 factor, 2 factors. So I can factor out, well, I have an x to the 2/3 and an x to the -1/3. So I'm going to factor out x to the -1/3. Okay. So now, remember, always lower power. So that means I have -1 times x to the what? So x to the what? So -1/3 plus 1 gives us 2/3. So this is x to the first. And then I have plus 2/3 times 1 minus x. And I took out the x to the -1/3. All right, so now that's first derivative set equal to 0. So if I continue here, I'm going to set x to the -1/3 equal to 0, and then I'm going to set this thing, so -1x plus 2/3, and then distribute minus 2/3 x equal to 0. All right, so x to the -1/3, when is that equal to 0? Well, never equal to 0, because that means 1 over the cube root of x. Of course, that can't equal 0, but if the cube root of x equals 0, then that means that this function, f prime, would be undefined. So I cube both sides, I get that x equals 0. Not 3. X equals 0, so make yourself a note here. X equals 0 makes f prime undefined. All right, so that's good. All right, so now this one. -1x minus 2/3 x. So that'd be -3/3 minus 2/3 is -5/3 x plus 2/3 equals 0. So I subtract 2/3, divide by -5/3. So -2/3 divided by -5/3. Remember, that's like multiplying by -3/5. So the 3's, of course, are reduced. I get positive 2/5. All right, so x equals 2/5. So I'm going to prepare to complete a sign analysis of f prime. Okay, and I'm going to put 0 and 2/5 on my number line. All right. Now, before I do that, I'm also going to find f double prime. All right, so f double prime. All right, that's going to be the derivative of the derivative. Now, I'm going to use the simplified version, right? So the simplified version here is x to the -1/3 times, and then this became -5/3 x plus 2/3, right? That's the simplified version of f prime. So now I'm going to use the product rule. All right, so product rule, f double prime. So I'm going to take x to the -1/3 times the derivative of -5/3 x plus 2/3. That would be -5/3. All right, and then plus -5/3 x plus 2/3 times the derivative of x to the -1/3, which would be -1/3 x to the -4/3. All right, so now I'm going to set this equal to 0 and solve just like the previous one. All right, so in order to solve this, all right, so I have x to the -1/3 and x to the -4/3. So I'm going to factor out an x to the -4/3 because that's the lower power, and I could also factor out an x to the, or sorry, a -1/3 x just to make things a little bit nicer. All right, so if I do that, what do I get? Well, I factored out an x to the a -1/3. So I have a 5, and then I have x to the -1/3, so I'd have x to the what? Well, -4/3 plus 1, once again, is -1/3, so this would be 5x. And then I have plus. Now I took out a -1/3, x to the -4/3, so I just have the -5/3 x plus 2/3 remaining. All right, so now I'm going to set each one of those equal to 0. -1/3 x to the -4/3 equals 0. Of course, that is never equal to 0 because what does that mean? It means 1 over 3 times the third root of x to the 4th, which cannot be 0. But what do you know? That x equals 0 would also make f double prime undefined, which is something that you would have already known because f prime was undefined at x equals 0. All right, so then I continue on here, and I have 5x minus 5/3 x. All right, so 5x, that would be 15/3 minus 5/3 is 10/3 x. plus 2/3, and so equals 0. So I subtract 2/3 divided by 10/3. So x equals negative 2/3 divided by 10/3. So if I'm dividing by 10/3, that's like multiplying by 3/10, right? And so what does that mean? I get x equals negative 3's reduced, so negative 2/10 or negative 1/5. So now I already had x equals 0, so now I'm going to put x equals negative 1/5 on my number line. So now I'm going to do f prime above this line and f double prime below the line. All right, so now above the line, okay, I'm going to put my factors of f prime. All right, so what are my factors of f prime? So that would be x to the negative 1/3, and then I had negative 5/3 x plus 2/3. All right, so that's f prime. Below the line, I'm going to put f double prime. F double prime was negative 1/3 x to the negative 4/3, and then I had the 10/3 x plus 2/3. All right, so now I have 2 rows for f prime, and I had 2 rows for f double prime. All right, so on the top row, I'm going to put a u above 0 because, remember, the first derivative was undefined when x equals negative 1/3. Then I'm going to put a 0 above 2/5. All right, so now I have those intervals. All right, then on the bottom row, I'm going to put a u below 0. And then I'm going to put a 0 below negative 1/5. All right, so now I have each of these intervals that I'm going to be working with. All right, so now on the top row in the first derivative, if I pick a number to the left of 0, like a negative number, and I say like negative 1 to the negative 1/3, remember, what does this really mean? It means 1 over the cube root of x. So 1 over the cube root of negative 1 is, of course, negative. Okay, number to the right, like positive 1. 1 over the cube root of positive 1 is positive. All right, then for this factor, negative 5/3 x plus whatever that was, 2/3. Sorry, it's hard to read that. All right, so if I pick a number to the left of 2/5, all right, like 0. Negative 5/3 times 0 plus 2/3 is positive over here, right? All right. Then a number to the right, like 1. Negative 5/3 times 1 plus 2/3 is negative. All right. So the first derivative is a negative times a positive, which is going to be a negative. Negative times a positive is a negative. Positive times a positive is a positive. And a positive times a negative is a negative. So these are the first derivatives. So now we are able to answer increasing, decreasing, local extreme values. Okay? All right, so I'm sorry that you might be running out of room here, okay, but let's go ahead and answer those questions. F is increasing on what interval? All right, so it is increasing on 0 to 2/5. All right, F is decreasing on what interval? That would be from negative infinity to 0, and then 2/5 to infinity. All right, so that's increasing, decreasing. All right, what about locals? Well, negative to negative, that does not indicate a local max or min. Negative to positive, right? Remember, negative to positive indicates a local minimum. All right, so you can write yourself a note, local minimum at x equals 0. All right, and then we have at 2/5 positive derivative to negative, so that would be local max at x equals 2/5. All right, so that's all first derivative stuff. So now, second derivative stuff. All right, so now let's take this. Negative 1/3 x to the negative 4/3. What does that mean? Remember, it means negative 1 over 3 times the third root of x to the 4th. So imagine we're taking a negative number, a number to the left of 0. So if I take a negative number and I raise it to the 4th power, it's positive, but the overall fraction is negative. So this would be a negative. All right, pick a number to the right of 0, like a positive. Well, if I take a positive number in for x and I raise it to the 4th, it's positive. But remember, the overall fraction is negative, and so this thing is negative. All right, bottom row here. Okay, pick a number to the left of negative 1/5. How about negative 1? 10/3 times negative 1 plus 2/3. Well, that would be negative 10/3 plus 2/3, which is a negative, right? So I put a negative over here. And then a number to the right, how about 0? 10 thirds times 0 plus 2 thirds, that is positive. All right, so now the second derivative is going to be a negative times a negative. Well, that's a positive. Negative times a positive is a negative. Negative times a positive is a negative, and negative times a positive is a negative. So now, thinking about the second derivative. All right, second derivative tells me when I can figure out concave up, concave down, and points of inflection. So you can say f is concave down on what interval? Well, concave down means f double prime is negative. So that would be from what? Negative 1/5, well, all the way to infinity, because the sign of the second derivative never changes to positive. All right, f is concave up on the interval, well, whenever f double prime is positive. So that'd be negative infinity to negative 1/5. All right, so now the other thing we can do with the second derivative is figure out points of inflection. So point of inflection, well, whenever f double prime changes sign. So positive to negative, negative, negative. So point of inflection only occurs at x equals negative 1/5. All right, and so now what we want to do is we want to use both the first and second derivative together to sketch a graph. All right, so I'm going to change color so we can see it a little bit more clearly. So now we're joining together the first and second derivatives in order to determine what the curve looks like. All right, so in the first section, okay, to the left of negative 1/5, we have a first derivative that is negative, which means the curve is decreasing, but a second derivative that is positive, so decreasing and concave up. Sorry, it should just go like this, right? All right, the next section between negative 1/5 and 0, it is decreasing and concave down. Decreasing and concave down, so something like that. All right? Next, between 0 and 2/5, positive first derivative, so increasing, negative second derivative, concave down, so something like this. And then lastly, negative first derivative, negative second derivative, so decreasing and concave down, so something like this. So now we're going to join together those four things. Okay, now on the previous example, I never knew what any y value was, but in this problem, I am given the original function. And so we can figure out a y value. So I usually just try to figure out the easiest y value. How about 0? What is f of 0? Well, f of 0 would be 0 to the 2/3 times 1 minus 0, which would be 0. So we're going to put a point at 0, 0. All right, so there's a point at 0, 0. So now we have this point is going to be at 2/5, and this point is going to be at negative 1/5. All right, so now at 0, 0, we have these two curves joining each other. So it would be somewhere at a corner point, right? Because those two curves must join together where the first derivative is undefined, right? So this would be a corner point, which makes sense. All right, now if I go to the right, I'm going to continue this curve here, and these two curves join together at a horizontal tangent because the first derivative is 0. All right, but what about over here? We have this concave down curve here, and then we have this concave up curve here. So we have a concave up curve and a concave down curve joining here, but it's important that you remember that the curve should not level off because the first derivative does not equal 0. So it would actually be some sort of a negative slope here, okay? All right, and so this would be the graph of that. You could always type this in your calculator and you could get this graph and you could see exactly what it looks like. All right, so that is slide number 27.